Hey y'all, welcome. Yeah, so I was doing math recently. Surprise, surprise. And and I came across this really interesting fact in geometry that, like, you know, we're going to prove. And I, like, it's right in your face. It kind of like, well, makes sense after the fact, but you know, like when you like hear the statement which I'm about to write, like, well, so read as opposed to hear, you'll really be like, whoa, shoot, I did not know that this was true, but it's cool. How do you prove this? So hopefully you do say that. Not sure. I did. So here goes. So the vertices of any right triangle, yes, any right triangle, are equidistant, meaning equally far away from the, yeah, I know, a little bit long, midpoint of the hypotenuse. Obviously, if it's a right triangle, its longest side is called the hypotenuse. And so we're saying that, like, the three vertices of any size right triangle are going to be equally far away from the midpoint of the hypotenuse. And all ambulances are equally annoying. Okay, all right, so there's a lot more of them in New York City than anywhere else, but I'm sure. It's like surprising that I haven't lost my mind yet, but I know it's still in my head. Okay. So let's get some drawings going, right? Like, so like, you know, like, what about this right triangle? What if we make it like a 12, 5, 13 right triangle? This would also work, and the 3, 4, 5. And yours truly is clearly like trying his best to make them look like as they should, figure drawn to scale, right? And so this is what we're saying. We're saying, like, let me try and use a different color. We're saying that if this is the midpoint of this hypotenuse, which it looks just about, then we're saying that this here, this distance, the straight line distance from the midpoint of the hypotenuse to this vertex is the same as this straight line distance to that. And of course, like, since this is the midpoint, comes as no surprise that this part and this part are equal. So what came as a surprise to me when I came across this yesterday is the fact that this too is, well, maybe I'm talking this up because some of you are like, hey, like, this is not that hard. So this is the proof, right? So let's just, it depends on who you are, but it may be hard, like, you know, if you're like a third grader. So this is what you do. It may seem hard, let's say. So you complete whatever triangle you're given. So like, if this is triangle ABC, then throw on like an A prime here. So now you have a rectangle AB A prime C, right? And since I said this is true for any size triangle, we don't need to have, you know, these precise lengths on them. So fine, how do we prove now that this here to the midpoint is the same as that, which in turn is equal to that? Well, very easy actually. So what we do is we draw this, right? And clearly, since we have a rectangle AB A prime C, we know that the diagonals of a rectangle are equal. So the length from here to here is equal to the length from here to here. But we also know, because a rectangle is a parallelogram, that the diagonals bisect each other. That is, for any parallelogram, the diagonals bisect each other. So that's something you can prove fairly easily in geometry. And it looks like I missed the midpoint. It's not there. It looks like it's here. But yeah, clearly, because the diagonals of a rectangle are equal, we know that this diagonal is equal to this diagonal. But then, because we know that the diagonals bisect each other, we know that this here is equal to this here. The length from here to here is equal to the length from here to here. But since this here in the first place was equal to this here, when we cut this in half, well, the two parts here will be equal to these two parts, and therefore that. So basically, the proof of this statement boils down to two simple facts. The fact that the diagonals of a rectangle are equal, and then the fact that the diagonals of a rectangle bisect each other. Because now what we could do is, look here, remove this extra drawing that I'd had here, and then voila. Yeah? Okay, cool. I hope you enjoyed this, and yeah, keep watching. Take care.